So, namaste to all. Welcome to the session. So, in today's class, we are going to discuss the topic that is thermodynamics. Thermo means we already know heat. Dynamics is it is in motion position. So, thermodynamics is also one of the branch of physics itself. So, in that, what we are going to study? In that, we are going to study, or that is one of the branch of physics that deals with concept of heat and temperature and interconversion of heat and other form of energy. So that we are going to study in this chapter. And we are coming across in this chapter, we are going to study, or it deals with the concept of heat and temperature and how the interconversion of heat and other form of energy is possible to convert. So that we are going to study in this chapter. And before entering into this chapter, so we should know some of the basic terminologies that is related to thermodynamics. So that is, what do you mean by open system? What do you mean by closed system? Some of the basic terminology related to thermodynamics we shall see. So here, thermodynamics is also one of the branch of physics. So how we are going to define this? That deals with concept of heat and temperature and interconversion of heat and other form of energy. So here, thermodynamics means, how we are going to define that one? So today we are going to discuss the topic that is thermodynamics. So thermodynamics is one of the branch of physics. In that, we are going to deal with concept of heat and temperature and interconversion of heat and other form of energy. And before entering into this, we shall know some of the important definitions related to thermodynamics. Those are, first we shall see the basic meaning of thermodynamic system. So thermodynamic system. So what is the meaning of thermodynamic system means? So thermodynamic system is, how we are going to define, what is the meaning of that? So thermodynamic system is, so it is defined, or it is a definite quantity of matter enclosed in a boundary. It may be real or imaginary. So a typical thermodynamic system is a gas in a container, or it may be molecules in a solution. So that we are going to call thermodynamic system anta kariತೀವಿ. So next we shall see what is the meaning of surrounding of the thermodynamic system. So surrounding anta yavudu kariತೀವಿ? Thermodynamics ಕಾನ್ಸೆಪ್ಟ್ ಅಲ್ಲಿ ಸರೌಂಡಿಂಗ್ ಅಂತ ಯಾವ್ದು ಕರಿತೀವಿ ಅಂತಂದ್ರ, ಸೊ ಎವ್ರಿಥಿಂಗ್ ಔಟ್ಸೈಡ್ ದ ಸಿಸ್ಟಮ್ ಅದನ್ನ ನಾವು ಸರೌಂಡಿಂಗ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ ಓಪನ್ ಥರ್ಮೋಡೈನಾಮಿಕ್ ಸಿಸ್ಟಮ್ ಅಂತ ಯಾವ್ದು ಕರಿತೀವಿ? ಸೊ ಲೆಟ್ ಅಸ್ ಸಿ, ಓಪನ್ ಸರೌಂಡಿಂಗ್ ಅಂತ ಯಾವ್ದು ಕರಿತೀವಿ ಅಂತಂದ್ರ, ಸೊ ಹಿಯರ್ thermodynamic system, it may be gas in a container irbodu, or it may be a molecules in a solution irbodu, that we are going to call thermodynamic system ant karitivi. And next, surroundings of thermodynamics ant yavudu karitivi andra, so that is everything outside the system that we are going to call surroundings anta kariತೀವಿ. So this is the basic terminology we are coming across in this chapter, that is thermodynamics. And here nodri, ಓಪನ್ ಥರ್ಮೋಡೈನಮಿಕ್ ಸಿಸ್ಟಮ್ ಅಂತ ಯಾವ್ದು ಕರಿತೀವಿ ಅಂತಂದ್ರ, ಓಪನ್ ಇರ್ಬೋದು, ಆಮೇಲೆ ಕ್ಲೋಸ್ಡ್ ಸಿಸ್ಟಮ್ ಅಂತ ಯಾವ್ದು ಕರಿತೀವಿ? ಸೊ ಓಪನ್ ಥರ್ಮೋಡೈನಮಿಕ್ ಸಿಸ್ಟಮ್ ಅಂತ, ಸೊ ಫಾರ್ ವಾಟ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಕಾಲ್ ಈಸ್ ಓಪನ್ ಥರ್ಮೋಡೈನಮಿಕ್ ಸಿಸ್ಟಮ್, ಅಂಡ್ ವಿ ಆರ್ ಕಮಿಂಗ್ ಅಕ್ರಾಸ್ ಕ್ಲೋಸ್ಡ್ ಥರ್ಮೋಡೈನಮಿಕ್ ಸಿಸ್ಟಮ್ ಅಂತೂ ವಿ ಆರ್ ಕಮಿಂಗ್ ಅಕ್ರಾಸ್. ಆಮೇಲೆ ಐಸೋಲೇಟೆಡ್ ಥರ್ಮೋಡೈನಮಿಕ್ ಸಿಸ್ಟಮ್ ಅಂತ ಯಾವ್ದಕ್ಕೆ ಕರಿತೀವಿ? ಲೆಟ್ ಅಸ್ ಸಿ ಒನ್ ಬೈ ಒನ್. ನೋಡಿ, ಓಪನ್ ಥರ್ಮೋಡೈನಾಮಿಕ್ ಸಿಸ್ಟಮ್ ಅಂತ ಯಾವ್ದಕ್ಕೆ ಕರಿತೀವಿ ಅಂತಂದ್ರ, ಸೊ ಹಿಯರ್ the thermodynamic system is said to be open. ಯಾವಾಗ? If it exchange both matter and energy with the surrounding ಇತ್ತು ಅಂದ್ರ that we are going to call open thermodynamic system ಅಂತ ಕರಿತೀವಿ. Same thing, closed thermodynamic system ಅಂತ ಯಾವಾಗ ಕರಿತೀವಿ? Thermodynamic system is said to be closed if it exchange only energy but not matter with the surrounding ಇತ್ತು ಅಂದ್ರ, so that is called as closed thermodynamic system ಅಂತ ಕರಿತೀವಿ. So next we are coming across isolated thermodynamic system. So for what we are going to call isolated thermodynamic system andra, the thermodynamic system is said to be isolated yavaga? If it does not exchange both matter and energy with the surrounding, ಎರಡು exchange ಮಾಡಲಿಲ್ಲ ಅಂದ್ರ, so that is called as isolated. Iso that is, it does not exchange both matter and energy so with the surrounding, that is called as isolated thermodynamic system. So nodri, so if you connect one with the another, so if you remember one thing, it can possible to tell another thing. Open thermodynamic andre it can exchange both matter and energy, but closed system it exchange only energy but not matter with the surrounding. Isolated thermodynamics andra, so it does not exchange both matter as well as energy with the surrounding. Adak ನಾವು isolated thermodynamic system anta karitivi. So these are some of the terminology we should know, because when we enter into the subject, understanding of these concepts is very important. And next we shall see some other basic terminologies, that is, so we saw the basic meaning of isolated thermodynamic system, and next we shall see what is the meaning of thermodynamic state anta yavadu karitivi. Let us see. And next, thermodynamic variables, or it is also called as thermodynamic coordinates antu karitivi. So for what we are going to call thermodynamic variables antandra, adana let us see one by one. So here we are seeing some of the basic terminologies. So those basic terminologies are isolated andra, so the system is said to be isolated thermodynamics. So if it does not exchange both matter and energy, so andra it is called as isolated thermodynamic system anta karitivi. So next, thermodynamic state anta yavadu karitivi. So it is the condition of thermodynamic system in which it exists, that we are going to call thermodynamic state we are going to call. And we are coming across thermodynamic variables, or it is also called as thermodynamic coordinates anta karitivi. So thermodynamic variables anta yavadu karitivi andra, thermodynamic system can be described in terms of its composition. So it may be pressure, temperature, volume, internal energy, entropy. So these concepts is ನಾವು ಏನಂತ ಕರಿತೀವಿ, thermodynamical variables ಅಂತ ಕರಿತೀವಿ. So you have to keep in remember in your mind, you have to remember this one. So the pressure, temperature, volume, internal energy and entropy, these are called as thermodynamical variables anta karitivi. The homogeneous thermodynamic system such as gas can be described completely using three variables. those three variables ಯಾವುದು ಪ್ರೆಷರ್, ಟೆಂಪರೇಚರ್ ಅಂಡ್ ವಾಲ್ಯೂಮ್. ಇವು ಮೂರನ್ನ ಯೂಸ್ ಮಾಡಿಕೊಂಡು ಸೊ ಹೋಮೋಜಿನಿಯಸ್ ಥರ್ಮೋಡೈನಮಿಕ್ ಸಿಸ್ಟಮ್ ಆಫ್ ಎ ಗ್ಯಾಸ್ ಕ್ಯಾನ್ ಬಿ ಡಿಸ್ಕ್ರೈಬ್ಡ್ ಕಂಪ್ಲೀಟ್ಲಿ. So by using three variables, that is pressure, temperature and volume. So you have to remember this one. And next we are coming across next concept, that is thermodynamic equilibrium. So for what we are going to call thermodynamic equilibrium means a system is said to be in thermal equilibrium or thermodynamic equilibrium if it is in a state of thermal, mechanical and chemical equilibrium. So a system is said to be thermal equilibrium ಅಂತ ಹೇಳ್ತೀವಿ ಯಾವಾಗ if the temperature of all its parts is same ಇತ್ತು ಅಂದ್ರೆ ಮಾತ್ರ so it is as that of surrounding same ಇತ್ತು ಅಂದ್ರೆ it is said to be thermal equilibrium. ಅಂದ್ರೆ ಏನಾಗುತ್ತಲ್ಲೇ with the surrounding thermal ಅಂದ್ರೆ heat, equilibrium ಅಂದ್ರೆ same position, ಅದಕ್ಕೆ ನಾವೇನಂತ ಕರಿತೀವಿ thermal equilibrium ಅಂತ ಕರಿತೀವಿ. So then when we are going to call mechanical equilibrium andra, so system is said to be mechanical equilibrium if there is no net force in the interior of the system or between the system and its surrounding ittu andra, so that is said to be mechanical equilibrium anta karitivi. So next concept, so that is when we are going to call chemical equilibrium andra, system is said to be chemical equilibrium if chemical composition is same throughout the system ittu andre chemical equilibrium anta karitivi. So thermodynamic equilibrium olaga so three types bartati. So first one is that is thermal equilibrium, mechanical equilibrium and chemical equilibrium. So we already know, so yaವಾಗ ನಾವು system is said to be thermodynamic equilibrium, thermodynamic equilibrium ಅಂದ್ರೆ in that state of thermal, mechanical ಮತ್ತು chemical equilibrium three types ಬರ್ತಾವ. System is said to be thermal equilibrium if temperature of all the parts is same with the surrounding ಇತ್ತು ಅಂದ್ರೆ thermal equilibrium ಅಂತ ಕರಿತೀವಿ. Suppose system is said to be mechanical equilibrium andre if there is no net force in the interior of the system ittu andre so it is said to be mechanical equilibrium. So chemical equilibrium anta yava karitivi andre if the chemical composition is same throughout the system ittu andre that is said to be chemical equilibrium anta karitivi. Thermodynamic equilibrium olaga three types bartava, that is thermal equilibrium, mechanical equilibrium and chemical equilibrium. Three types we are coming across. You have to remember these concepts. So next we shall see equation of state. So equation of state anta yavuduk karitivi antandre, so it is a mathematical relation between thermodynamical variables. ಯಾವ್ಯಾವು? So thermodynamical variables ಅಂತ ಯಾವ್ದು ಕರಿತೀವಿ? ಪ್ರೆಷರ್, ವಾಲ್ಯೂಮ್, ಟೆಂಪರೇಚರ್ ಗೆ thermodynamical variable ಅಂತ ಕರಿತೀವಿ. So the relation between these three variables ಯಾವುದು? ಟೆಂಪರೇಚರ್, ಪ್ರೆಷರ್ ಮತ್ತು ವಾಲ್ಯೂಮ್. So relation between three variables ಗೆ ನಾವೇನಂತ ಕರಿತೀವಿ? That is possible to give with mathematical formula, that is PV is equal to nRT. P and the pressure, V and the volume, R and the universal gas constant is the, that is temperature. N and the number of moles in the represent ಮಾಡುತ್ತೆ. Here we consider for perfect gas or ideal gas. Ideal gas ಅಂದ್ರೆ ಏನು? The gas which obeys the all gaseous laws ಗೆ ನಾವು ideal gas ಅಥವಾ perfect gas ಅಂತ ಕರಿತೀವಿ. So here mathematical relation between thermodynamical variables, that is pressure, volume and temperature, is given by the formula PV is equal to nRT. So our mathematical source is it. So next we shall see we are coming across some of the processes in thermodynamics. So those are thermodynamic process alli we are coming across mainly four processes: isothermal process, isobaric process, isochoric process and adiabatic process anta kariತೀವಿ. So when we are going to call isothermal, iso andre the meaning of iso means same, thermal andre temperature or heat anta ತಗೋತೀವಿ. So isothermal process andre it is the process in which temperature remains constant ಇತ್ತು ಅಂದ್ರೆ ಅದಕ್ಕೆ isothermal process ಅಂತ ಕರಿತೀವಿ. So isobaric ಅಂತ ಯಾವುದು ಕರಿತೀವಿ ಅಂದ್ರೆ ಅದರಲ್ಲಿ pressure, so it is one of the process in that pressure remains constant ಇತ್ತು ಅಂದ್ರೆ isobaric ಅಂತ ಕರಿತೀವಿ. Isochoric process, choric ಅಂದ್ರೆ it is the process in which volume remains same ಇತ್ತು ಅಂದ್ರೆ isochoric process ಅಂತ ಕರಿತೀವಿ. Adiabatic process ಅಂದ್ರೆ it is the process in which heat remains constant. ಆ process ಅಲ್ಲಿ ಯಾವ factor constant ಇಟ್ಟಿರ್ತೀವಿ ಅನ್ನೋದ್ರ ಮೇಲೆ we are giving the name as isothermal, isobaric, isochoric and adiabatic process ಅಂತ we are coming across different processes in thermodynamics. So those are I am going to show here. So that is for perfect gas equation that is given by, so that is the relation between thermodynamical variables that is given by PV is equal to nRT. And here thermodynamic process means, so thermodynamic process we are coming across so many process. Thermodynamic process, how we are going to define means it is the process in which there is a change in thermodynamic variables takes place. Based on we are classifying the thermodynamic variables into isothermal process, first one, and second one isobaric process, third one isochoric process, fourth one adiabatic process. Isothermal process ಅಲ್ಲಿ ಏನು ಸೇಮ್ ಇರುತ್ತಾ, temperature is remains constant. Same thing isobaric ಅಲ್ಲಿ pressure remains constant, isochoric ಅಲ್ಲಿ volumes remains constant, adiabatic process ಅಲ್ಲಿ heat remains constant. So here these are all about thermodynamic processes. So ನೋಡ್ರಿ ಒಂದನ್ನ ನೆನಪಿಟ್ರೆ ಇನ್ನು ರಿಮೈನಿಂಗ್ ಅನ್ನು ಈಸಿ ಆಗಿ ಡಿಫೈನ್ ಮಾಡಬಹುದು. ಸೊ ಥರ್ಮೋಡೈನಮಿಕ್ ಪ್ರೊಸೆಸ್ ಅಲ್ಲಿ ಅವು ಯಾವ್ಯಾವ ಫ್ಯಾಕ್ಟರ್ ಯಾವ್ಯಾವ ವೇರಿಯೇಬಲ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಇರುತ್ತೆ ಅನ್ನೋದ್ರ ಮೇಲೆ ವಿ ಆರ್ ಕಮಿಂಗ್ ಅಕ್ರಾಸ್ 4 ಟೈಪ್ಸ್ ಆಫ್ ಥರ್ಮೋಡೈನಮಿಕ್ ಪ್ರೊಸೆಸ್. And next we shall see what is the meaning of quasi-static process. So quasi-static process anta yavudಕ್ಕೆ ಕರಿತೀವಿ? So quasi-static process means, so in quasi-static process the temperature of the surrounding river and the external pressure differ only infinitesimally from the temperature and pressure of the system. Quasi-static process is obviously hypothetical construct. Actually in practice, process that are sufficiently slow, do not involve accelerated motion of the piston, large temperature gradient, etc. are responsibly approximation to an ideal quasi-static process. So quasi-static process is one of the process, it is a very slow process that you have to remember. And next we shall see thermal equilibrium. So when the system is said to be thermal equilibrium, let us say, so thermal equilibrium. And next we shall discuss about zeroth law of thermodynamics. So here, the system is said to be thermal equilibrium. Yavaga, if the temperature of all its parts is same with the surrounding ittu antandra, that is said to be thermal equilibrium anta karitivi. And in thermodynamics chapter, we are coming across 3 laws of thermodynamics. Those are zeroth law of thermodynamics, first law of thermodynamics, and second law of thermodynamics we are coming across. First, we shall discuss or we shall see about zeroth law of thermodynamics. So here, the zeroth law of thermodynamics, in order to explain that one, so I consider 2 bodies. You can consider any 2 bodies. Let us consider A and B are the 2 bodies. So here, according to zeroth law of thermodynamics, so we are considering 2 bodies. Let us consider first one is A and second one is B. So if 2 bodies A and B are separately in thermal equilibrium with third body C. So we consider 2 bodies A and B. Suppose these 2 bodies are in thermal equilibrium with another body, that is C body. So then the bodies A and B are said to be in thermal equilibrium. Example is ಹೇಳಬೇಕಾಗಿತ್ತು ಅಂದ್ರೆ, so ಇಬ್ರು friends ಇರ್ತಾರೆ. So these 2 friends are connected with someone. ಅಂದ್ರೆ C ಅನ್ನೋನು ಕೂಡ ಇವರಿಬ್ರಿಗೂ ಫ್ರೆಂಡ್ ಇದ್ಲಂದ್ರ, ಸೊ ಅವನಿಗೆ ಇವನ್ ಫ್ರೆಂಡ್ ಅಂತ ಹೇಳ್ಬೋದು, ಇವನಿಗೆ ಇವನ್ ಫ್ರೆಂಡ್ ಅಂತ ಹೇಳ್ಬೋದು. ಯಾಕಂದ್ರೆ ಬೋತ್ ದೇ ಆರ್ ಕನೆಕ್ಟೆಡ್ ವಿತ್ ಈಚ್ ಅದರ್. Same thing, if 2 bodies are considered, if they are in thermal equilibrium ಅಂತ ಯಾವಾಗ ಹೇಳ್ತೀವಿ ಅಂದ್ರೆ, with if it is connected with a third body C, then A and B are said to be in thermal equilibrium. So ಅದನ್ನೇ ನಾವು ಯಾವ ತರ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ಬೋದು ಅಂತಂದ್ರೆ, so we can possible to explain like this. The statement of zeroth law is like this: if 2 bodies A and B are separately in thermal equilibrium with a third body C, then body A and B are said to be in thermal equilibrium. So this is the statement of zeroth law anta kariತೀವಿ. So ಇದನ್ನ ಹೆಂಗೆ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ಬೋದು ಅಂದ್ರೆ, we considered 2 bodies, that is A and B. ಎರಡು ಬಾಡಿ ಕನ್ಸಿಡರ್ ಮಾಡಿವಿ. Both they are in thermal equilibrium ಅಂತ ಯಾವಾಗ ಹೇಳ್ತೀವಿ? So here for A, that with the help of thermometer we can possible to tell both are connected with another body C. So here, according to zeroth law of thermodynamics, both the bodies A and B are in thermal equilibrium with the third body C, then the body A and B are said to be in thermal equilibrium anta kariತೀವಿ. So ಅದನ್ನ ಯಾವ ತರ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಬಹುದು? We can possible to explain in your own words. That is, so let us consider 2 bodies A and B. So if you consider 2 bodies A and B, so here I am going to considering the object A and B. So A and B, and if it is connected with C, so let the thermometer be the third body. Adana C anta tagondivi. So it measures the particular temperature when it is in contact with A. If it measures the same temperature when it is in contact with B, then according to zeroth law of thermodynamics, so A and B are at the same temperature. So that is A and B are in thermal equilibrium anta helbodu. So you can explain in your own words this one. Here we consider 2 bodies A and B. So these 2 bodies are in thermal equilibrium. Yavaga? So one thermometer ತಗೊಳ್ರಿ. Let us consider that is third body ಅಂತ ಅನ್ಕೊಳ್ರಿ. A and B are the 2 bodies that we consider. So the thermometer, it measures the particular temperature when it is contact with A ಜೊತೆಗೆ ಇಟ್ಟಾಗ ಅದರ ಟೆಂಪರೇಚರ್ ಮೆಜರ್ ಮಾಡ್ತೀವಿ. If it measures the same temperature when it contact with B ಜೊತೆಗೆ ಮಾಡಿ ಅದರ ಟೆಂಪರೇಚರ್ ಮೆಜರ್ ಮಾಡ್ತೀವಿ. So according to zeroth law of thermodynamics ಪ್ರಕಾರ A and B are having same temperature. ಯಾವಾಗ? A and B are in thermal equilibrium iddaga matra A and B are at the same temperature anta helbodu. So this is according to zeroth law of thermodynamics. And what is the significance of zeroth law of thermodynamics, Sandra? So the temperature can be defined using zeroth law. Yavaga? When two bodies are said to be in thermal equilibrium. So the significance of zeroth law of thermodynamics is the significance of zeroth law of thermodynamics is. So what is the significance? So let us say the significance of zeroth law of thermodynamics is, so the temperature can be defined using zeroth law. Two bodies are said to be in thermal equilibrium if their temperatures are same ikkandra matra they are said to be thermal equilibrium antivi. Therefore temperature is the degree of hotness or coldness. Already we learned this one. So one more point you have to remember, the requirement of zeroth law that was recognized after first law. So zeroth law is more fundamental than the first law. Hence, the name zeroth law is to indicate that this law produces the first law. This is how to keep in your mind. So here, next we shall see internal energy of the system. So what is the meaning of internal energy of the system? We shall see. So internal energy of the system. So internal energy of the system ಅಂತ ಯಾವುದು ಕರಿತೀವಿ ಅಂದ್ರೆ it is the sum of kinetic energy possessed by all the particles constituting the system by virtue of their vibrator ಇರಬಹುದು, rotator ಇರಬಹುದು or translatory ಇರಬಹುದು. So here internal energy of the system andra, so here internal energy of the system, it is the sum of kinetic energy possessed by all the particles constituting the system by virtue of their vibratory, rotatory or it may be translatory motion. And one point you have to remember, relation between heat energy, work and internal energy is given by first law of thermodynamics. So heat and work are not thermodynamic variables, but internal energy is a thermodynamic variable anta kariತೀವಿ. And the relation between heat, energy and work and internal energy is given by first law of thermodynamics. And let us see about first law of thermodynamics. So first law of thermodynamics, what it states is, according to first law of thermodynamics, what is the statement? So according to first law of thermodynamics, this is the statement. So here the heat energy absorbed by a system is equal to the sum of increase in internal energy and external work done by the system on the surroundings. So that is a statement of first law of thermodynamics. So I will explain madbodu. Let dq be the amount of heat absorbed by the system and tolana. du ಅನ್ನೋ symbol that is used to represent increase in internal energy ಅಂತ ತಗೊಳ್ಳೋಣ. dW ಅನ್ನೋದು be the external work done ಅಂತ ತಗೊಳ್ಳೋಣ. So according to first law of thermodynamics ಏನು, it is the sum of increase in internal energy and external work done by the system and the surrounding. So that is given by dQ is equal to du plus of dW. So this first law of thermodynamics, it is based on law of conservation of energy. Alva? So the significance of first law of thermodynamics is nothing but law of conservation of energy. And mathematically, first law of thermodynamics is given by the formula. So ಯಾವ formula use ಮಾಡ್ತೀವಿ? So dQ is equal to du plus of dW. So it is significance of the first law of thermodynamics is, so it is based on law of conservation of energy. So first law of thermodynamics, it is based on law of conservation of energy. So dQ ಅಂತಂದ್ರೆ ಏನು represent ಮಾಡುತ್ತೆ? Amount of heat absorbed by the system ಅಂತ ಅರ್ಥ ಅದು. And ಇಲ್ಲಿ ನೆಕ್ಸ್ಟ್ du ಅಂತ ಯಾಕೆ ಯೂಸ್ ಮಾಡ್ತೀವಿ? ಇನ್ಕ್ರೀಸ್ ಇನ್ ಇಂಟರ್ನಲ್ ಎನರ್ಜಿ. du ಅಂದ್ರೆ ಏನ? ಇನ್ಕ್ರೀಸ್ ಇನ್ ಇಂಟರ್ನಲ್ ಎನರ್ಜಿ. ಅಂಡ್ dQ ಅಂತಂದ್ರೆ ಏನು? ಅಮೌಂಟ್ ಆಫ್ ಹೀಟ್ ಅಬ್ಸಾರ್ಬ್ಡ್. ಇದು ಹೀಟ್ ಅಬ್ಸಾರ್ಬ್ಡ್. dW ಅಂದ್ರೆ ಏನು? ದಟ್ ಈಸ್ ನಥಿಂಗ್ ಬಟ್ ಎಕ್ಸ್ಟರ್ನಲ್ ವರ್ಕ್ ಡನ್ ಅಂತ ರಿಪ್ರೆಸೆಂಟ್ ಮಾಡಕ dW ಅಂತ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ದಟ್ ಈಸ್ ಎಕ್ಸ್ಟರ್ನಲ್ ವರ್ಕ್ ಡನ್. And the significance of first law of thermodynamics is based on law of conservation of energy. So what is the statement of first law of thermodynamics? The heat energy absorbed by a system is equal to the sum of increase in internal energy and external work done by the system on the surrounding. And mathematically it is represented by dQ is equal to du plus of dW. And the significance of first law of thermodynamics, it is based on law of conservation of energy. So this is all about first law of thermodynamics. And next we shall see what is the meaning of isothermal process. Iso andre same, thermal andre heat process. In that process what it happen, let us see. So here isothermal process. So here isothermal process ಅಂತ ಯಾವುದು ಕರಿತೀವಿ ಅಂದ್ರೆ, it is the process which takes place at constant temperature. It is called as iso ಅಂದ್ರೆ same, thermal ಅಂದ್ರೆ that is nothing but what it is. Iso same, thermal means temperature or heat remains constant.